Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our first PU Computer Science online classes. Now, in last class we know that we studied some important concept from Introduction to C++, maybe some of the binary operators, and we know that the meaning of the binary operators, the operator which act on two operands are called as the binary operators, and such binary operators are classified into arithmetic operators, logical operators, relational operators, bitwise operator, assignment operator, and the special operators. Now today's in class we are going to complete the fourth point of the operator in our binary operator, that is the bitwise operator. As we know that in last class we already completed the first one is the arithmetic operator, relational, and the logical operator. So in today's class I am going to start the fourth point of the binary operator, that is the bitwise operator. Now what about the bit? As we know that the meaning of the bit is the binary digits, correct? No, the bit full form is the binary digit here, and the binary digits values are 0 and 1, only call as the bit point here. So what about the bit in this case? So here we can say that the bit, or we can say about the bitwise operator works on bits and perform bit by bit operation. That means here we are not going to take any other value, okay? Here just only the values are 0 and 1 only. So we can start with the word the binary or the bitwise operator works on bits and perform bit by bit operation. So the truth table, now this is called as the truth table of the bitwise operator, and always should remember it. Maybe the truth table going to start by using the value 0 0 0 1 1 0 1 and 1 only. So the truth table for the bitwise operator are as follows here. So in this case the bitwise here and operator, just only one symbol is called as the bitwise and operator, and this is called as the bitwise or operator. Now this is the symbol of the bitwise and operator, and this is the symbol of the bitwise or operator, or also called as the inclusive operator, bitwise inclusive operator, and this is called as the bitwise exclusive operator. Clear this point here? Or bitwise Xor operator. So all these are called as the bitwise operator. As we know, let's study the truth table for the bitwise and bitwise or and the bitwise Xor operator here. As we know that, first of all, before going to do some of the operation, first we need to take some of the variables, some of the values in the variable A and B. So here I am going to take the values in the variable 0 0 0 1 1 0 1 and 1 only here. Now what about the bitwise and operator? How it going to work in case of the bitwise and operator? Now I am in this concept here, the bitwise and operator, okay here. So in this case we can say that the bitwise and operator give the result as 1. Clear this point here? The bitwise and operator give the result as 1 here. That means when it going to give the result as the 1 if the corresponding bits in both the values are 1. Clear this point here? ಯಾವಾಗ ನಮಗೆ bitwise and operator ಅಲ್ಲಿ result 1 ಆಗಿ ನಮಗೆ ಸಿಗ್ತದೆ, ಯಾವಾಗ ಅಂತ ಹೇಳಿದ್ರೆ if the corresponding bit in both the values are 1. ಯಾವಾಗ ಎರಡು ವೇರಿಯೇಬಲ್ ಅಲ್ಲಿ a ವ್ಯಾಲ್ಯೂ ಕೂಡ 1 b ವ್ಯಾಲ್ಯೂ ಕೂಡ 1 ಆದಾಗ ಮಾತ್ರ ನಮಗೆ ರಿಸಲ್ಟ್ 1 ಆಗಿ ಡಿಸ್ಪ್ಲೇ ಆಗ್ತದೆ. Otherwise it will give the result as the 0 only. So clear this point here. What about how it going to work the bitwise AND operator? Okay, I am repeating. The bitwise AND operator give the result as 1 if the corresponding bits in both the values are 1. Otherwise, it will give the result as the 0. Okay. Now after completing the bitwise our AND operator here. Now we will go for our the bitwise OR operator. Okay, kya? As we know that this symbol it works or it looks like the horizontal symbol top to down. Okay, kya? This symbol is called as the bitwise OR operator or bitwise inclusive operator. Kya? So this is the symbol. Now how it going to work in case of our bitwise OR operator here. So we can say that the bitwise OR operator give the result as 1 here. Here we can say that if either or both of the corresponding bit in the values are 1. Clear this point here? Maybe if either. So in this case when you are going to see here 0, 1. If either. Correct no here? And the second step also it holds the value as the 1, 0. In before that step we can say that 0, 1 here, and in next step 1, 0 here, but after that the 1 and 1. So when it going to give the result as the 1 in this case here, so we can say that the bitwise OR operator give the result as 1 if either or both of the corresponding bits are 1. Clear this part here? Otherwise it will give the result as the 0. So because of this we'll get the 1, 1, 1. So the result will give as the 0, 1, 1, 1. ಅರ್ಥ ಆಯ್ತಲ್ಲ? bitwise OR operator ಯಾವಾಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಕಡೆ 1 ಆಗಿರಬೇಕು, otherwise in both of the side it should have the value 1 here. On that time only it will give the result as the 1, otherwise it will give the result as the 0 here. Okay, now this is about our bitwise OR operator. Now let's about our bitwise exclusive OR operator or the bitwise our Xor operator. Clear this point here? The bitwise, this symbol is called as the exclusive operator, the bitwise exclusive operator or Xor operator. So Xor operator. So what about the Xor operator here? When it going to give the result as the 1 in this case, so we can say that the bitwise exclusive operator will give the result as 1 in this case if any one of the corresponding bit are 1. Clear this point here? If any one of the corresponding bit is 1. So when you are going to check here, first value is the 0, 0, sure it will give the result as the 0 only here. Next step 0, 1. I already said if any one of the corresponding bit is 1. Correct no? So 0, 1 sure it will give the result as the 1 in this case. 1, 0 and here also will give the result as the 1 only, but here both ones are there, that means sure it will give the result as the 0 only. So clear this point here. What about the bitwise AND operator, the bitwise OR operator and the bitwise Xor operator, that is called as the exclusive OR operator. Correct no? So in case of the bitwise AND operator, that means if corresponding bit in both the values are 1, then only it will give the result as the 1 here. And what about the bitwise OR operator? So in case of the bitwise OR operator, we can say that if either or both of the corresponding bit is 1, then it will give the result as the 1 in this case here. And what about the bitwise Xor operator or the exclusive OR operator here? If any one of the corresponding bit is 1, then that means it sure give the result as the 1 only. Okay, now after completing the bitwise AND operator, the bitwise OR operator and the bitwise exclusive OR operator here, now let's the fourth point of the bitwise operator, that is the bitwise ones complement operator. Okay, so this is the side point, the bitwise ones complement operator. So how it going to work in case of the bitwise ones complement operator? So we can say that it reverse of all the values of all the bits. Clear this point here? It reverse the value of all the bits in this case here. So this this is the meaning of the bitwise all operator, or in simple words we can say that all the ones present in the number are going to change to the zeros here, and all the zeros are changed to the 1. Clear this point here? So we can say that how it going to work in case of bitwise ones complement operator. ಎಲ್ಲಿ ನಮ್ಮ 1 ಇರ್ತದೆ ಆ number 1 going to change to the 0 here, or wherever the value 0 is there, it will going to change such a value to the 0 only. Clear this point? So here one example I want to use. So if this is the example, here I used the 40, that means sure wherever the value 0 is there, sure it going to change such a value to the 1 here, and here 4 ones are there, so we'll give the result as the 0. Or maybe one more example, 1010. So this is the example. If they ask in examination, just write the ones complement of the number, how we are going to take. That means the value 1 is that you need to change to the 0, 0 is that change to 1 here, 1 is that change to 0, and 0 is that change to 1. So this is the answer of the ones complement bitwise operator, or bitwise ones complement operator. So clear this point, the meaning of the, that means it reverse of all the values of the bits in this case here, and all the ones present in the number are changed to the zeros, and all zeros are changed to the ones here in our bitwise ones complement operator. Okay, after completing the bitwise ones complement operator, now let's the next thing about our right shift operator. Okay, it is also going to join in our bitwise operator only. Some of the types or the classification of the bitwise operator, that is the right shift operator. Right shift operator. Now this symbol is called as the bitwise right shift operator here. So what about the right shift operator? So we can say that it shift each bit in the operand to the right side. Clear this point here? So ಅದು ಯಾವ ಸೈಡ್ ಗೆ ಶಿಫ್ಟ್ ಮಾಡ್ತದೆ, ಯಾವುದೇ ಒಂದು ಬಿಟ್, ನಮಗೆ ಗೊತ್ತಿದೆ ಬಿಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಬೈನರಿ ಡಿಜಿಟ್. ಸೊ ಅದರಲ್ಲಿ ಬರುವ ವ್ಯಾಲ್ಯೂಸ್ 0 ಮತ್ತೆ 1 ಮಾತ್ರ. ಸೊ one example here I want to take as the 1100111110. So that means in this example just only the values 0 and 1 are there. Other than no any values I want to use in case of the bit operation 0 and 1 only. I am going to form the example by using the bitwise operation. Clear this point here? Okay, now we know that it shift each bit in the operand to the right side. Correct? No, right side, that means it going to move in this manner here. So this is called as the right side. That means we are going to write 1100. So when you are going to write, that means the bit are going to move in the right manner here, right side manner here. So it shift each bit in the operand to the right side, and 0 is added to the left of the number. Clear this point here? This 0 is added to the left of the number. So this is the explanation. I know maybe little bit confusion. Now let's, by using the example, we are going to solve whatever I explained in our right shift operator. I said in our right shift operator, it shift each bit in the operand to the right side, and 0 is added to the left of the number. So if the variable num contains the bit pattern operation, the bit pattern operation is the 1 1 0 0 1 1 1 and 0. Clear this point here? Now by using such example, I want to do right shift operator. I want to move all the bits to the right shift manner. Clear? So the example is, again I want to repeat, the example values are the, that means the num variable contain the bit pattern, in this case here 1 1 0 0 1 1 1 1 0. So this is the example. So in this example, now I want to use for example the num, right shift operator 1 gives the value, that means this is the result here. So we know that first of all we need to write, how we need to write, as we know that I already used the arrow key. Correct? Now how the bits are going to move to the right side in our right shift operator, I already said it shift each bit in the operand to the right side. So I am going to start, I am using the values 1 1, I am going to start from the value 1 1, and I am going to move in this manner. Clear this point here? So it's going going to move in this manner here. So this is called as the right shift operator. So I am using the value 1 1 0 0 1 1 1 1. But what about the last value? Why? Because here already you should know it, the num value right shift 1 only, that means the 1 operator, the 1 value. So lastly we will get the value as the 0 here. So the 0 is added to the left of the number. Clear this point here? ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ನಾನು ಯಾವ ವ್ಯಾಲ್ಯೂ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ, ಯಾಕೆಂದ್ರೆ ನಮಗೆ ಗೊತ್ತಿದೆ ರೈಟ್ ಶಿಫ್ಟ್ ಬಿಟ್ ವೈಸ್ ಆಪರೇಟರ್ ಹೇಗೆ ಮೂವ್ ಆಗ್ತದೆ. ಸೊ ಇಟ್ ಗೋಯಿಂಗ್ ಟು ಮೂವ್ ಟು ದಿ ರೈಟ್ ಮ್ಯಾನರ್ ಓನ್ಲಿ, ರೈಟ್ ಶಿಫ್ಟ್ ಮ್ಯಾನರ್ ಓನ್ಲಿ, ಆರ್ ಮೇ ಬಿ ಡಿಪೆಂಡ್ ಆನ್ ದಿ ವ್ಯಾಲ್ಯೂ, ದಟ್ ಮೀನ್ಸ್ ದಿ ಒನ್ ವ್ಯಾಲ್ಯೂ ವಿ ನೀಡ್ ಟು write or we need to add to the left of the number. And always remember it, maybe the last value is 1 or 0, while going to add to the right side of the number should use the value as the 0 only here. Clear this point here? So we can say that this is the example. Listen it properly how it going to move here. So the 1 1, so I am using the value 1 1 0 0 here, and later next one 1 1 1 1. If last 0 is there, no, going to add to the left of the number. So this is the example of the right shift operator. Now let's maybe some confusion in our first example. It will be clear in our second example. So in this case, now just only the question is the num right shift operator 3. So how it going to give the result in this case? The question is the num right shift operator 3. Okay, so it will give the result as the, first of all I am going to start, I know that we know that about this one how it going to move. That means it shift each bit in the operand to the right side. So I am starting from the number 1 1. So 1 1 0 0, and later just only 1 1 here is that. So I am going to write now later words. Finally we'll take 3 values, remain the 3 values here. So 3 or 0 is added to the left of the number. Because of this reason, this 0 we need to add to the left side of the number of the right shift operator. So clear this point? So it will give the result as the 0 0 0 1 1 0 0 1 1 here. So this is the result of the right shift operator. ಅರ್ಥ ಆಯ್ತಲ್ಲ ಎಲ್ಲರಿಗೆ? Maybe the last value is 1 1 0, but we need to change such a value to the 0 only, and such a 0 depend on the number, maybe the 1 and 3 going to add to the number to the left side of the number here. So this is about our right shift operator here. So clear? Okay. Now after the right shift operator, the next thing about our left shift operator, as we know that this symbol is called as the left shift operator. Clear this one? So here we can say that just only whatever we written for the right shift operator, just in the reverse manner we need to write for our left shift operator here. So what about the left shift operator? So we can say that it shift each bit in the operand to the left side. Clear this point here? Left side, as we know that the left side means like that we are going to write 1 0 1 0 1 0. So in this manner we are going to write. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ರೈಟ್ ಶಿಫ್ಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಹೇಗೆ ಬರೀತಿದ್ವಿ? ರೈಟ್ ಶಿಫ್ಟ್ ಅಂತ ಹೇಳ್ತಿದ್ರೆ 1 1 0 0 1 1. ಕರೆಕ್ಟ್ ನೋ? So like this it will going to move one by one in this case here. But now we are in the concept of the left shift operator, then sure we need to write from this manner here. So this is called as the left shift operator. So we can say that it shift each bit in the operand to the left side, and 0 is added to the right of the number. Clear this point here? This 0 is added to the right of the number. Now let's in the example, if the variable ch, okay, kya contain the bit pattern is the, for example 1 1 0 1 0 1 1 1. It is the example. By using such example I am going to show the result of the left shift operator depend on the value, maybe the 1 value or the 3 value here. Clear this point here? So we can say that if the variable ch here contain the bit pattern here, the bit pattern is the 1 1 0 1 0 1 1 1. So how to write the result of the left shift operator? Now let's the ch, and later next one is the left shift operator 1 will give the result as the So first of all we need to write, we know that the right shift anta helidre now ee tara in this manner we are going to write, correct no kya, left shift anta helidre now in this manner we are going to write in this case. So first of all I am going to take the value as the 1 1 1, okay. So later words let's such value we need to write here. So 1 1 1 0 1, okay, 0 1, and now just only last one is left in this case, but in this case we need to write 1, correct no. So in this case we can say that the 1 means the 0 is added to the right of the number. So CH, our left shift operator will give the result as the 1 0 1 0 1 1 1 0. So this is the answer of the left shift operator. Now let's the last example for the left shift operator here. So this CH and later next one left shift operator 3 give the result as the for example we know that how we need to start in this case here. First of all we need to start by using this point, correct no. So 1 1 1 here 1 1 1 and later next one 0 1. Now how many, that means 3 values we need to add to the right of the number. So 0 1 1 is that, but whatever this 1 is that, 0 is that, such one going to change to the value 0 only. So 0 is added to the right of the number. So this is the answer of this CH, and left shift operator 3 gives the result as the our 1 0 1 1 1 0 0 0. So clear this point here. So again just only last point I want to say about our right shift operator. If you know the meaning of the right shift operator, just only you can reverse such meaning to our left shift operator. But in case of the right shift operator, it shift each bit in the operand to the right side. We know that means such one going to move in this manner, correct no. Here this is our right hand and this is called as the left here. So that going to move in our right side here, and 0 is added to the left of the number. But left shift operator, that means it shift each bit in the operand to the left manner, correct no. So left manner means it going to move in this manner here, left manner, and 0 is added to the right of the number. We already saw by using the example both our operator like our right shift operator and the left shift operator. Okay, as we know that the binary operators are many types are there: arithmetic operators, relational, logical, and just only we are in the concept of the bitwise operator. We already know the bitwise AND operator, the bitwise OR operator, the bitwise XOR operator, bitwise ones complement operator, and bitwise right shift operator and bitwise left shift operator here. Now the next fifth point, assignment operator. But before going to know or before going to start the assignment operator, that is the division of the binary operator, now let's one more simple concept, that is the C++ shorthand. Clear this one. Now we are not in the concept of the bitwise operator. Now just I selected the new concept. Before going to, we know that many types of the classification of the binary operators are there, but later words I will tell the next types of the binary operator, that is the assignment operator. Before that we need to complete, or we can say that we are going to complete the C++ shorthand. So what about the shorthand in this case here? So we can say that in our C++ programming language offers some special shorthand. Clear this point here. The C++ language, as we know that the C++ is a OOPS programming language in this case here, and such language providing or offer some special shorthand, and that simplify the assignment of a certain type of assignment statement here. Clear this point here, that providing some of the assignments. So the one example we can say in case of the C++ shorthand, A is equal to A plus 10. Clear this point, A is equal to A plus 10. So how we are going to write by using the shorthand in our C++? So A is equal to A plus 10 is same as, or maybe can be write as the, or written as the A plus equal 10. Clear this point here? So first of all ನಾವು ಹೇಗೆ ಬರ್ದಿದ್ದೇವೆ, ದಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ a is equal to a plus 10 ಆಗಿ ನಾವು ಬರ್ದಿದ್ದೇವೆ. ಅದೇ ನಾವು ಶಾರ್ಟ್ ಹ್ಯಾಂಡ್ ಅಲ್ಲಿ ಹೇಗೆ ಬರಿಬಹುದು? ಸೊ ಶಾರ್ಟ್ ಹ್ಯಾಂಡ್ ಅಲ್ಲಿ ನಾವು ಬರಿಬಹುದಾದ್ರೆ ನಾವು ಅದನ್ನು ಜಸ್ಟ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ ದಿ a plus equal 10 in this case here. So we can say that the operator, pair operator in this case. So the pair operator is the plus equal, correct no kya? The operator, pair operator, that is the plus equal, tells the compiler to assign the value to the a plus 10 only, correct no? A is equal to a plus 10 only. Maybe we know that this is called as the full hand in this case, but such one going to write by using the shorthand a plus equal 10 kya, correct no? Why? Because here we are using the pair operator together. So the pair operator is the plus equal, and such a pair operator tells the compiler, that means software, to assign the value that is equal to the our that is equal to our a plus 10 only, correct no kya? So now we know that how we are going to write the shorthand example in this case. So let's the general form of C++ shorthand, or the general form, or we can say that the syntax of the general form or the syntax of the C++ shorthand here. So such a syntax we can write as the variable operator is equal to expression, correct no? So the variable, correct no? Operator means our plus, or we can use the minus also, no any problem, but here we already used one example as the plus. A is equal to a plus 10. So let's, by using such example only, we can write the example for the general form of C++ shorthand. So variable name I want to use as the a operator, that is the plus, equal sign as it is, no any changes, and the expression value that is equal to 10. So by using the general form we can write the general form as well as the example of the C++ shorthand. So we can say that the variable operator is equal to expression. Clear this one kya? Expression. Now let's the following, or we can say that some of the example of the C++ shorthand. Maybe in case x minus equal 10, x minus equal 10 is same as x is equal to x minus 10. Clear this point here? So illi now shorthand alli bardideve one by one, many of the shorthands are there. Now how to write in our full form in this case here? So we can say that the x minus equal 10 we can write, or that is same like our x is equal to x minus 10. This second example, x multiplication is equal 5, x multiplication is equal 5, that is equal to x is equal to x into 5 here. And the third example, x divide by is equal to 2. Clear this one here? The x divide equal to, that is equal to x is equal to x divide by 2. Clear this one? X is equal to x divide by 2 here. And later next one is the x modulus is equal to z here. How we are going to write? X is equal to x modulus z. Clear this one here? So we can say that all are the example for our, or the list of the C++ shorthand. After completing the bitwise operator, as we know that many types are there in our bitwise operator, and also in this class only we completed C++ shorthand, and we know that maybe the a is equal to a plus 10 can be write in shorthand as the a plus equal 10, correct no? So the general form, that is the general form or the syntax of the C++ shorthand, variable, and later next one we need to write operator here, equal, expression. And we know that we already completed some of the example. Okay, now in our binary operators we know arithmetic operator, logical operator, relational operator, bitwise operator. Now let's the fifth point of the operator of the binary operator, that is the assignment operator. So now in case of the assignment operator, which symbol is going to use here? So equal sign is called as the assignment operator. Clear this point here? The equal sign is called as the assignment operator. So why we using the equal sign and where we using the equal sign? So we can say that such equal sign or assignment operator are used to assign a constant value or an expression value to a variable. For example, a value is equal to 10. Clear this point here? Just only to assign value to the variable we using the assignment operator. So the assignment operator are used to assign the constant value or any expression value to a variable here. Now what about the meaning of the compound assignment operator? So we can say that when the assignment operator combined with the arithmetic operators, we know the meaning or the some example of the arithmetic operators: addition, subtraction, multiplication, division and modulus are called as the assignment operator. So when assignment operator equal sign combined with the arithmetic operator, then such operator are called as the compound assignment operator. Clear this point here? Now let's some of the example of our assignment operator and also some of the example for the compound assignment operator. So the first column name is the operator, and in this column I am going to use some of the operator here, and in second column what's the meaning or how to call such operator here. Clear this point? Or we can say that the description or the meaning of the operator, and the third column I want to use some of the example of the operator here. So clear this point? Okay, now our first column equal sign. So how to call such operator? Such operator we can call as the simple assignment operator. Clear this point here? The simple assignment operator, just only the equal sign. Now it is not called as the compound assignment operator. The meaning of compound assignment operator means here the assignment operator combined with arithmetic operator. So it is not the example of the compound assignment operator. So such equal sign is called as the assignment operator or simple assignment operator. So for example, C is equal to A plus B. That means we can say that we'll assign the value of A plus B into C. Maybe if you are using any value, A value is 10 and B value is also 10. Now such value going to assign to the variable C. So C value is equal to 20. Correct? No, here. So we can say that we'll assign. So for example, C is equal to A plus B here. We'll assign the value of A plus B into C. Okay. And later next one, now this is the suitable example of the our compound assignment operator plus equal. So such operator is called as the add and assignment operator. Clear this one? Addition, plus is there, plus equal, add and assignment operator. Now the example, C plus equal A. How to write? So C is equal to C plus A. Clear this point here? C is equal to, so this is the example of the shorthand. Correct? No? Shorthand. C plus equal A here. So such one going to write or return as the C is equal to C plus A here. Okay? And later next one is the next assignment operator minus equal. So such operator is called as the subtract and assignment operator. Clear this point? The subtract and assignment operator. So one example we can write as the C minus equal A. So how to write in full form? That is C is equal to C minus A. Clear this one here? So this is the example of the subtract and assignment operator. And after that, now some other operator that also going to join in our assignment operator, that are the multiplication equal. Clear this point here? The multiplication equal. So such operator is called as the multiply and assignment operator. Clear this one? Multiplication, that is equal to the star equal. So multiply and assignment operator. So maybe example we can write as the C multiply equal A here. So such one going to write as the C is equal to C multiply A. Okay. So this is the example or the full form of C multiply equal A here. And later next one, the next operator is called as the divide equal. Okay. The divide equal also one example for the compound assignment assignment operator किया. So we can say the divide and assignment operator. So the example is the C divide equal A किया. So such one going to write as the C is equal to C divide by A. Okay. So this is the example of the full form किया. And later next one, as we know that if you are using it to look like a percentage symbol, but such symbol in our C++ programming language called as the modulus. Okay क्या? MODULUS, modulus and assignment operator. The modulus and assignment operator. So one example, if you are going to write as the C modulus is equal to A, C modulus is equal to K, such one going to write as the C is equal to C modulus A. Okay क्या? So this is the full form क्या? And later next one, after that the left shift equal, correct no? The left shift equal, so such one we can write the description as the left shift and assignment operator. The left shift, as we know that in our bitwise operator, one operator name is there and how it going to work, how it going to shift to the which manner. The left shift going to shift to the left side, but 0 is added to the right of the number. So this operator, so in case when you are going to use the left shift equal sign is called as the left shift and assignment operator. So one example, C left shift is equal to 2 here. So such one going to write C is equal to C left shift 2. Okay. So this is about our full form, and like that only some other operators are the right shift equal. Okay क्या? The right shift equal. So we can say that the meaning as the right shift and assignment operator. The right shift and assignment operator. So one example, C right shift is equal to 2. So such one can be write as the C is equal to C right shift 2. C is equal to C right shift 2 here. And later next one, as we know that this operator only call as the bitwise and operator, correct no? The bitwise and operator. So we can say as the bitwise and assignment operator. If you are using just only ampersand, it is called as the bitwise and, but if you are using ampersand equal, then it is called as the bitwise and assignment operator. So one example, C bitwise and equal 2 here. So C is equal to C bitwise and 2. Clear this point here? So C is equal to C bitwise and 2. Okay. And later next one, so this operator is called as the bitwise exclusive, correct no? Xor operator. So we can say as the bitwise exclusive or an assignment operator. Okay here? So just only this is called as the bitwise Xor operator or bitwise exclusive or operator, but if you are using equal, it is called as the bitwise exclusive or an assignment operator. So C we can say that exclusive or equal to 2. So C is equal to C exclusive 2 here. So this is the full form here. And lastly, such last operator is called as the our inclusive or, the bitwise inclusive or bitwise or operator. Okay. So we can say as the bitwise inclusive or and assignment operator. So the shorthand, C we can say the bitwise or equal to, so C is equal to C bitwise 2 here. So all are some of the example of the assignment operator. As we know that if you are using equal, just only call as the assignment operator, but if you are using any arithmetic operator with equal sign, it is called as the compound assignment operator. We already know some example, that is equal sign and plus equal, minus equal, multiplication equal, divide equal, left shift equal, right shift equal, and bitwise and equal here. The bitwise exclusive or equal and bitwise inclusive or equal. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.